Our next presenter is a senior scientist employed by KBR and contracted to NASA's Human Research Program at the Johnson Space Center. Dr. Patrice Yarbough is principal investigator for the Human Exploration Research Analog. With expertise in human immune systems and viral infections, Yarbough explores how humans behave in confined isolation in preparation for long-duration space mission. But can she explain it in 5 minutes? Or Houston, will we have a problem? Please welcome Patrice Yarbough.
Houston, we have an analog. I am a scientist, and scientists make discoveries and a living by asking questions. If the questions are well defined and if the answers are acquired with procedures in a controlled environment, then the resulting data can be tested for robustness by repeating the procedures better known as experiments. As NASA prepares for missions to Mars and far-away places in our galaxy, researchers are using ground-based analogs to study the impact of living in space on people. One analog known by the acronym HERA for Human Exploration Research Analog is used to better understand how humans behave in confinement and isolation away from friends and family for extended period of time. Our studies inside HERA started in 2014 and are funded by the NASA Human Research Program. We have a team of scientists and engineers from the NASA Civil Service workforce and NASA contractors. Our team wants to solve problems that will happen while living in space. Better yet, we want to predict the problems and develop the countermeasures. Maybe you have heard that NASA locks up 4 strangers in an isolation unit in Houston for 45 days and watches their every move. As the principal investigator of the complement of these studies, please allow me a few minutes to tell you about the who, what, when, where, and how of HERA. HERA is a 3-story habitat on site at Johnson Space Center that we use to study human subjects while they participate in mission-like scenarios. Our team creates simulated missions that allow the researchers to explore the physiological and psychological stressors that develop during the mission. Our subjects inside HERA conduct tasks similar to what the astronauts do on the International Space Station. We collect data that is applicable to our astronauts, and we use this data to inform our future astronauts. Travel outside of low Earth orbit will take a long time, so we want to observe the impacts to behavior and better understand how soon can we detect changes that might impact performance. Our study investigators are asking questions like, what influences team function? How do crew members adapt over time? And how well do the subjects perform when they are tired or stressed? Everything in HERA is planned to 5-minute intervals for every day of the 45-day mission. Subjects only have contact with each other and the HERA mission control. A few HERA definitions are going to help you understand the study design. We have 3 teams that manage and monitor the details. Our operation team designs the mission and the tasks and activities for the 45-day mission. The current mission is a simulation of 715 days of travel to and from an asteroid. We have a simulated mission control that observes the crew 24/7 and interfaces with them to troubleshoot as NASA mission control functions for the ISS. Our medical team of NASA physicians meet the crew weekly to monitor overall health. Our subjects follow a timeline. There are 8 cameras inside of HERA to monitor all crew interactions, and I monitor the study and the subject compliance. The most important part of the study is the subjects. The subjects are randomly assigned a role of commander, flight engineer, mission specialist 1, and mission specialist 2. Once the subjects are selected as a crew, we prepare them for the mission with 2 weeks of training at JSC. They learn flight simulation, communication delays, and are trained on equipment. We aim for a 50-50 ratio of males to females. Subjects wear devices that capture data, voice recorders, actigraphy watches, and heart rate sensors. Although our studies are designed for application to the astronauts, there are everyday applications to our research in behavioral assessments, such as post-traumatic stress disorders in our military, stress in our inner cities, and what has been observed as an increasing incident of depression and anxiety disorders in our youth. The common question is, how does stress, any stress, impact our bodies? And what are the early predictors of such human response to stress? Our NASA research has widespread impact potential. We expect that what we will learn from the collective missions of 30 and 45 days of confined isolation will keep our city of Houston a beacon for continued research for space exploration.